Okay, let's do the chapter 21, part 2 problems, which is mostly on equivalent resistance and circuit diagrams. Now, this particular chapter is really important to, draw things, and you don't have to be an artist, but drawing is important because it helps you to visualize. And once you visualize, you're better able to solve problems. Let's start with number 17. So the before situation is just Ohm's law, V equals I Rec. We can get that from the givens. So that means we're going to have a current of 0.60 amps. Now, after what happens is that we have given a pathway for the electrons, and this pathway allows them to avoid the 12 ohm bulb. Now, since the electrons have this pathway, right, there's no reason for them to go into that right-hand loop of the circuit. And so this is what we mean by a short circuit. It's literally a shorter circuit, but it's short because the electrons are avoiding the resistance of the 12 ohm bulb. And so it's just not going to light at all. So now the situation we have is the resistance is only going to be 8 ohms because the 12 has been eliminated. So using Ohm's law there, we have a current of 1.5 amps. Now, I am not going to have you do every single problem in this problem set. I'm actually only going to be going through 10, and the numbers that I've circled are the ones I expect you to do. You're certainly welcome to do the other ones because the more practice you get, the better. But I'm only going to grade you on 10 of them. So 19 would be one of those optional problems. All right, let's go to 22. So 22 is asking for the equivalent resistance. And since these resistors are all in parallel, we do 1 over Rec equals 1 over 2.0 plus 1 over 3.0 plus 1 over 6.0. And the equivalent resistance is 1.0 ohms. In 31, similar problem, 1 over Rec, and 1/2 plus 1/3 plus 1/6 plus 1. And then what we do is we have to add, and the reason we're adding is because we do one equivalent resistance, and then we also know that we're putting that in series with another resistor, so that's why it's 5 plus 1/2. With series, you just add things up, and that gives us 5.5 ohms. In number 38, we have parallel resistors, so 1 over Rec equals 112 plus 1/6, and we get an Rec of 4 ohms. So for the whole circuit then, the Rec is 4 plus 4 plus 2, which is 10 ohms. Now, keep in mind that we have a 4 ohm resistor in series with a 6 and 12 parallel combo, which is in turn in series with a 2 ohm resistor. And that's where the 4 plus 4 plus 2 comes from. All right, now the V2 equals V3. And we know that because that's what parallel arrangements give us. They give us equal voltage in all branches. And we know that V2 equals I2 times 12 because V equals IR. And so V2 is 12 volts. And since V3 is equal to it, we know that is I3 times 6. We put 12 in for V3, and we can solve for I3, which is 2 amps. Now notice that in the path, and you should really remember this when you're doing diagrams, is you want to have arrows representing your currents, because again, this helps you to visualize things. All right, now if I1 equals I2 plus I3, based on the sketch, since I1 branches into I2 and I3, I1's 3 amps. So then we can bring that over and we say I1 equals V over Rec. That's just from Ohm's law. 3 equals V over 10, so our voltage is 0.03 kilovolts. Now another way to do this problem is just use Kirchhoff's rules. All right, so we've got our junction rule, which is I1 equals I2 plus I3. Get that from the sketch. And then we can use any two loops. We have three unknowns, so we want three equations. We can use the bottom loop and the top loop. All right, and the bottom loop, notice what it includes. We start with a battery, and then we do minus 4I1. That 4 is referring to this 4 ohm resistor right here. Then we have minus 6I3, and that's this 6 ohm resistor. And then we have minus 2I, 2 ohm resistor, equals 0. So the bottom loop that we're talking about starts at battery, goes up around, and then comes down here, and then goes back around. All right. The top loop is the one that's just this top little loop up there. All right. So using the loop rule equation there, we have positive 6I3. Why positive? Because I can navigate this loop any way I want with my pen, right? Or with your finger, whatever. That's arbitrary. But you have to keep in mind what you're doing, and you have to ask yourself at each stop along the circuit, does my chosen direction of pen or finger line up with the current, or does it not line up with the current? When you're dealing with a resistor and your chosen direction does not line up, then that would be a voltage jump. But when your chosen direction does line up with the current, as it does with the 12 ohm resistor, in that case, we have a voltage drop at resistors. And so that's why it's minus 12I2. Now, the rest of the problem is really just, algebra and using a matrix. You don't have to even use a matrix in Gaussian elimination in this particular problem. You can just use algebra and substitution and everything, and find out that your V is 30 volts. All right, so either method works for number 38. Okay, number 84. We are asked to find the branch currents, and so we're going to use Kirchhoff's rules. Our branch rule equation is I1 plus I2 equals I3. We can call that junction rules, probably better. So I1 plus I2 equals I3 according to the junction rule. How do we get that? Because we got a current coming up here, and then notice what it does when it reaches the junction, right? They merge into I3. Now, why do we have I1 coming off a battery and I2 coming off a battery? Because that's normally how you want to start. It's a reasonable guess. We start with reasonable guesses, and then we just kind of go from there. And it's usually reasonable to have currents coming off the positive terminal of a battery. Now, it's not always true, but even if you guess incorrectly, you're just going to find the magnitude to be negative, and then you can switch it later. All right, so I1 plus I2 is I3 according to the junction rule. Now our left loop is this guy over here, and our right loop is this guy over here. Let's look at the left loop. Okay, when your chosen direction, in this case we're going counterclockwise. We're going clockwise. So when your chosen direction matches up with the current arrows, well, in that case, a battery is a voltage jump and a resistor is a voltage drop. But when the opposite direction, or when the directions contradict, then a battery is a voltage drop and a resistor is a voltage jump. Okay, so let's look at the left loop. All right, 12 positive voltage jump. And then, since I'm going clockwise, I1 matches the direction of the way that I'm going around the loop. So I have minus 6I1. And then again, going clockwise, I3 matches my chosen direction. So minus 3I3 equals 0. In the right loop, it's convenient to just go counterclockwise. Okay, so if I go counterclockwise, I start at the battery, so 12 voltage jump, minus 6I2, because my chosen direction lines up with the current. and then minus 3i3 for the same reason. We now have a system of 3 equations, and we can plug those into a matrix in our calculators as I showed you in the video. If any of you still have questions about that, then by all means ask me, and I can walk you through the calculator steps for that. And then we find I1 equals 1 amp, I2 equals 1 amp, and I3 equals 2 amps. All right, let's continue then. So the next number is 88. And here it's more of the same, except that we're really just finding, we're finding I1. The method is going to be still using Kirchhoff's rules. All right, with the junction rule and the loop rule. So junction rule, we have I1 plus I2 equals I3. Now, where did that come from? Well, I1, reasonable guess is that comes off the positive terminal of the 10-volt battery. I2, reasonable guess is that it comes off the positive terminal of the 2-volt battery. And then I1 and I2 meet up at this junction right here that I'm pointing to. And at that junction, I1 joins I2 to make I3. So that's where the first equation comes from. Top loop, that refers to this guy right here that I'm outlining. That's top loop. And bottom loop would be this guy down here that I'm outlining. That's bottom loop. Okay, so top loop then. Let's say we want to go around it clockwise. Well, if we go around it clockwise, we got positive 2 from the 2-volt battery. Voltage drop from the resistor, since chosen direction lines up with current. So that's where the minus 2i2 comes from. And then minus 3i3 equals 0. Bottom loop, convenient again to go clockwise, although you could have chosen to go counterclockwise, wouldn't matter. You would just have to switch the positives and negatives. Okay, so then positive 10-volt battery. We go up around, and now here's a pretty interesting thing. If I am choosing the clockwise direction because it's convenient for the bottom loop, okay, I'm going around and around, right? Notice that when I get to the 2 ohm resistor, my chosen pen direction of clockwise is counter to the direction of the current I2. And so now the resistor is not a voltage drop. The resistor is considered a voltage jump. And that's why I have plus 2i2. Same with the battery. You see, I'm going clockwise, but that's counter to the direction of I2, and so I do minus 2 for that battery. But then, once I get to this part of the loop, notice that I1 matches my chosen clockwise direction, and so the resistor is a voltage drop again, and that's why I write minus I1. So that's the system of 3 equations. We don't necessarily need to use a matrix now. We can just kind of plug in the things we know. But either way, whatever method you choose, you're going to easily be able to find that I1 is 4 amps. Number 89, we have pretty much the same type of thing. And so this is our drawing. We have I1 plus I2 equals I3. That's our junction rule equation. The perimeter loop, let's talk about what that is. The perimeter loop is this big loop here that I'm tracing, okay? Which is just that, it goes around the perimeter. And then the top loop is going to be this loop at the top that I'm tracing right now. Now, could we have done bottom instead? Sure. In fact, we have 3 possible loops here. We've got bottom loop, top loop, and perimeter loop. And you can choose any 2 of the 3 because you only need 3 total equations to solve for 3 unknowns. All right, so then we do our perimeter equation, and if we say that we're going to go clockwise, actually, sorry, I was doing top. Perimeter equation. If we say that we're going clockwise around this perimeter, well, then I have a positive V, all right? I have a minus 4.0 I1. I go up here and I have a minus 8.0 I3 because the 2 4.0 ohm resistors are in series, just make it 8. And then back down here to 12, At all times in the perimeter loop, my chosen clockwise direction lines up with the currents. Now in the top loop up here, say we're going clockwise again, positive 24 volts, minus 6.0 I2, and then minus 8.0 I3, and then finally minus 2.0 I2. So here again, the chosen clockwise direction matched up with the current at all points. Okay, so that then the system then becomes I1 plus I2 equals 2.0. We're plugging in things we know now. And then basically just doing the algebra on all those things and using our givens, we can find that V is 32 volts. Okay, moving down to 91. Okay, so 91, again, similar. By now you should be getting used to Kirchhoff's rules. Remember, or you can probably see just how important accurate drawings are. They don't have to be nice, but they should help you visualize things. I1 equals I2 plus I3. That's our junction rule. A way to think of it is that I1 goes to this junction that I'm pointing at, and then branches out into I2 and I3. Okay, bottom loop, that's this guy down here. Top loop, that's this one up here. We use the same method as in previous problems, and we come up with our bottom loop equation, our top loop equation. And then we can get a matrix. So this matrix would be 1, negative 1, negative 1, 0. This one would be negative 3, negative 2, 0, negative 18, 0, negative 12, 6, negative 6. And finally, if we do the Gaussian elimination on that, we find I1 equals 2.0 amps, I2 equals 1.0 amps, and I3 equals 1.0 amps. Okay, 95 we're going to skip, but you can definitely do it for practice later on. I'll just kind of show you my sketch in case you're interested in doing it. You can pause the video if you need to, and then I'll show you my equations. And pause if you need to, and I'll also show you the solution and the answers. All right, but that's not a graded problem. Okay, now let's go up to 85. More Kirchhoff's rules, everyone's favorite. I1 equals I2 plus I3. The top loop, 3I3 minus 6I2. Now, notice why it's 3I3. Let's go over the top loop, okay? So if I'm going to go clockwise in the top loop, at the bottom here of that top loop there, my chosen clockwise direction does not match the direction of I3. Therefore, a resistor is a voltage jump. So this is positive 3I3. But then they do line up, and since the 3 is in series with 3, this is a total of 6 up there at the top branch, and so that would be minus 6I2. Okay, bottom loop, 20 minus 8I1, and then over here we have minus 3I3, and at all times clockwise does match currents. And so we end up with a matrix of 1, negative 1, negative 1, 0, 0, negative 6, 3, 0, negative 8, 0, negative 3, negative 20. Put that matrix into your calculators, do reduced row echelon form, or RF, and you'll find that we have I1, 2, and 3 of 2 amps, 2/3 amps, and 4/3 amps, respectively. Okay, 86 then. Actually, I just realized that I went out of order, but doesn't matter. So 86, we look at this diagram, we can see that we've mapped out the currents. I1 comes off the top, or the positive terminal of the 12-volt battery, I2 off of the unknown voltage battery. And then they meet in the middle at this junction and form to make I3. So I1 plus I2 equals I3, junction rule. We've got left loop over here, and going clockwise on left loop, right loop over here, and we're going counterclockwise on right loop. Of course, you could have chosen your own directions, it doesn't matter. All right, and then we know I3, so we can plug it in down here and use it to solve for our unknowns and get a voltage of 8 volts. All right, We've now gone through the 10 circled problems. Those are the ones that will be graded. I do encourage you to do the other ones just for extra practice. Please let me know if you need any help with the calculator things like Gaussian elimination, or if you have any other questions. All right, see you in class.